Hi everyone, in this video we're going to discuss rational expressions. We'll look at how to reduce rational expressions, multiply rational expressions, divide rational expressions, add and subtract rational expressions. So let's first start with the main basic property that you need to know, and that's the cancellation property, which means if you have A times C and B times C, and you can notice that the common factor of C, both in the numerator and denominator, you can factor it out or divide it into each other. And then you're left with just A over B. And so notice that we canceled out the C's. Just also be careful, both the B and C can't be 0, because if they were 0 here, then you'd have 0 in the denominator and it'd be undefined. So it's one of the big things we always have to make sure we know. So the first thing we're going to discuss is how to reduce a rational expression to lowest terms. Now, we spent a fair amount of time discussing factoring, and that's what you're going to use here. You're going to factor the numerator being what's on top of the fraction, and then you're going to factor the denominator. Now, be mindful that we have a basic idea of how we think about factoring first. So you have, first thing you want to think about is your GCF. Is there a greatest common factor? Then, if there's two terms, you want to think about a difference of perfect squares. If there's three terms, you want to think, okay, well, is the coefficient in front of the x squared term equal to 1? Or is the coefficient of the x squared term greater than 1? Remember, that means ax squared plus bx plus c, and this a being 1, or in this case, this a being bigger than 1. And then what if there's four terms? Well, then you want to use grouping. In this specific question, we're dealing with these, right? So we're dealing with 1 in front of the x squared. So we're just going to look at regular old factoring trinomials. So what that means is we're going to look at factors of 9 that add up to give you 6. So what's also helpful is you can list your factors of 9, and that helps you come about in thinking about what your factors are at all times. So 3 and 3 work. So you make two parentheses, an x and an x goes in front, and you put those two numbers in, 3 and 3. This tells you the sign's the same, and since it's plus, they're going to be positive. Now let's do the same thing with the denominator. Factors of 6, when are added, give you 5. So let's list our factors of 6. 1 and 6, 2 and 3. Well, 2 plus 3 gives you 5, so the denominator will be x plus 2, x plus 3. And I chose two plus signs because this tells me the sign's the same, and this tells me they're both positive. Now let's look using that cancellation property. Notice that there's an x plus 3 and an x plus 3 common to both numerator and denominator, so we can cross it out. But it only do it one time. You can't cross out the other x plus 3 as well. So your answer is x plus 3 all over x plus 2. Please do not tell me that the answer is 3 over 2, because you cannot simplify this anymore. You cannot cross out the x's. So if you do something like this, that's not allowed. It has to stay like this, and that's not allowed because you can't cross out with addition. Only if it's C multiplication. That's how we're able to cross those out. Okay, so let's look at this question now. So using that same idea as before about the GCF is the first thing you look for, and then you look for 2 terms, 3 terms, or 4 terms. I notice in my numerator I have 2 terms, so first think GCF. So notice that there is a greatest common factor in the first term, and that's x. So you take out the x divided by x is 1, minus x squared divided by x is x. Now there's nothing else I can do. This is not a difference of perfect squares, so that's just your simplified version of the numerator. Now this is a 1x squared, so we're just going to factor this. Factors of 2, when are subtracted, give you 1. So I think about 2 only has 2 factors, so they've got to put those numbers in. They're going to be different. This tells me the signs are different, and this tells me what the bigger number is going to be. So 2 is bigger, right? So that's going to get the plus sign. Now, notice what's unique here is that these sort of look the same. The only difference is that they're in reverse order. So here's a rule that you need to remember. If you have, and I'll bring just this specific one out here, This technically, you don't have to ever repeat this for me. I'm just going to show this to you why this works. Let's say I factored out a -1 from the numerator. So if I took out a -1 from the first term, it becomes -1. If I took out a -1 from -x, it becomes plus x. Now, I'm just going to rearrange this parentheses, and I'm going to write this as x minus 1. And notice that that's the same. Now, I'm allowed to do that because addition is commutative, which means you can switch them. So now, using the cancellation property, this leaves me with -1. So here's a big rule you want to notice, is that if you have exactly the same binomials with a minus sign between them, but it's reversed, the reduction it can be factored into -1. Notice if this was x minus 1 all over x minus 1, that would be positive 1, right? Because they're exactly the same. But because they're reversed order, and that's specifically what you have here in this question, when I simplify it, I'm going to be left with a -1, not just 1. So notice now this is going to become x times -1, so that's a negative x, all over just the x plus 2, which is left. Remember, this is multiplication of those two, so that's why it's a -x up in the numerator. Okay, let's talk about now what we would do if we multiply or divide rational expressions. So let's say we have one fraction a over b, and we have another fraction c over d. When you multiply them, you're really just going to multiply straight across, and you're going to get a times c all over b times d. Just also note that b cannot equal 0 and d cannot equal 0. Now what's going to happen is if you have common factors in any of these, you can cross them out using the cancellation property like we did before. So you're going to see that in the next example. Now this is multiplication. Now what if it was division? What if it's a over b divided by c over d? Well, you never want to work with division with fractions. Instead, you keep the numerator and then you multiply by the reciprocal. So the word I used here was reciprocal. So reciprocal just means flip. So if you notice, what we did is we flipped the denominator. Another way we say it is we could do keep, change, flip. So notice we kept the numerator the same, we changed it to multiplication, and we flipped it. And now it's really just like the multiplication rule up here, so your product will be a times d times b times c. And what cannot be 0 in these questions is b can't be 0, d can't be 0, but also c can't be 0. Okay, so now let's try this example at multiplication. It's quite similar to the questions we were doing earlier, only now you have not just one fraction, but two fractions. So we're going to use the same strategy, and we're going to factor each part of the fraction at a time. So let's work with the numerator first. So this is a regular trinomial factoring, so we're going to do numbers that multiply to give you this 4. They add up to 4. So if I think about 4, I have 2 and 2, right? So x goes here, because that's what gives you the x squared, and then you have a 2 and a 2. The signs are the same, they're both negative. Now we're going to do the same thing for the denominator. This denominator is 2 terms, so remember the chart we did before. If it's 2 terms, you think GCF first, then difference of perfect squares. This is a GCF. The greatest common factor is x. When you take x out of x to the third, you're left with x squared. When you take x out of x, you're left with 1. And it's a plus sign. Now let's do the same thing with this numerator. This numerator, it's 2 terms again, but it's not a difference of perfect squares. It's also a GCF. So 3 is the common factor. If you take 3 out of the first term, you're left with x squared. And you divide 3 out of the second term, you're left with 1. And then lastly, let's look at the denominator here. This is a trinomial where the coefficient is 1, just like similar to the one up here. So you're going to look at numbers that multiply to give you 2, add up to give you 3. So that's going to be 2 and 1. The signs are the same. They're both negative. Now we look for common factors from numerator to denominator. So notice that we have an x squared minus 1 here and an x squared minus 1 here, so they can cancel out. I have an x minus 2 here and an x minus 2 here. That can cancel out. There's no other common factors, so we write our answer. You multiply straight across, so it's going to be x minus 2 times 3. And then with the denominator, x times x minus 1. And that's your answer. Okay, now let's try this example. This example deals with division. So remember, your first step when you have division is to keep, change, flip, which means you want to make it a multiplication. So you keep the first fraction on the top, and then you change to multiplication, and you take the reciprocal of the bottom fraction, or we say flip. Now, once you write this, you then have to factor all the pieces of the fraction. So you factor the numerator of each, the denominator of each. So the x plus 5, that can't be factored anymore, so you keep it just as x plus 5. Now let's look at the x squared minus 16. That's a difference of perfect squares. Perfect square, perfect square. So remember the rule for difference of perfect squares. You take the square of the first term, and then you take the square of the second term, and then you just put different signs. Multiplication. Now let's do the numerator, this one. Factors of 4, when are added, give you 4. That's 2 and 2. The signs are the same, they're both negative. And let's now do this one. Factors of 10, when are subtracted, give you 3. That's going to be 5 and 2. Signs are different, bigger one's positive. Now let's start factoring. So x plus 5 and x plus 5, x minus 2 and x minus 2, and that's it. So in the numerator, we're left with x minus 2, and in the denominator, we're left with x plus 4 times x minus 4. Now let's talk about adding and subtracting fractions. So if you remember back in the day when you add or subtracted fractions, let's say you had 1/4 plus 1/4. You can only add fractions if they have like denominators, so this would then be 2/4. Let's say you had 3/4 minus 1/4, same idea. They have to have like denominators, 3 minus 1, 2/4. So that's basically what our first strategy we're going to do here is make sure they have like denominators. And if they have like denominators, then you can add them or subtract them depending on what the operation is. Okay, so let's look at this example. First thing you do is you acknowledge what type of operation it is, so it's plus. Then you say, okay, if I'm adding fractions, they have to have like denominators, which in this example it does. So that means you just write the denominator one time, and then you write the numerator plus the numerator. So 2x squared plus 6x plus 3x plus 4. And so the only like terms you have here is the 6 and the 3. So you're going to have 2x squared plus 9x plus 4 all over 2x minus 3. Now, you might be able to factor the numerator. So the numerator now is where the coefficient is bigger than 1. So we can use a strategy called slip and slide. So what the slip and slide strategy says, okay, we're going to take this 2x squared plus 9x plus 4, and we're going to multiply the 2 with the 4. So instead we're going to do x squared plus 9x plus 8, and you factor that. Factors of 8, when are added, give you 9. Well, that's going to be 8 and 1. The signs are all positive. But the problem is that we really did change the question. So what you have to do is, since we multiplied by 2, we're now going to divide both of those by 2. When you divide both of those by 2, this first parenthesis becomes x plus 4. But the second one can't do anything to simplify it. So what we do is we slide it up front. and we get 2x plus 1. And that's the simplified version of this numerator. So this will become x plus 4, 2x plus 1, all over 2x minus 3. All right, so now what if it's a subtraction between two fractions? So the same idea. First, make note of what operation it is, which is subtraction. If you're adding or subtracting fractions, you have to have like denominators, which you do, so that's excellent. So that means you write the fraction with just the denominator one time. But now we're going to subtract them, so it's going to be 5x minus 3. But then you're subtracting the entire right side fraction's numerator. So that numerator has to have a distribution of that negative sign. And then you combine like terms, so we have 5x minus x, so that'll be 4x. And then you have minus 3 minus 1, so that's minus 4. If it's x to write it in completely factored form, you have to take out the GCF in the numerator, and that would be your simplified answer. So the next question is, well, what if we don't have equal denominators? What if you have two different values? So let's look at a question that you would have had in the past. What if you have 2/5 plus 3/4? You can't add those. The denominators are not the same. So what you need to get then is a common denominator. And oftentimes, the common denominator that you can find would just be the multiplying of the two denominators together. If we want a least common denominator, you want to make sure that's the smallest common factor between them. In this case, it still is 20. So that means I'm going to multiply both the numerator and the denominator by what would give you that common denominator. So 4 times 2 is 8, 4 times 5 is 20, so I'm just doing that multiplication, plus 3 times 5 is 15, 4 times 5 is 20. Now notice they have common denominators now, so I can write it and add them, and 8 plus 15 is 23, and that is your answer. Now we're going to try this strategy using rational expressions. Let's try this example. 3x all over x minus 4 plus 2x all over x plus 3. So your common denominator, firstly notice that they're not the same denominators, right? So you have to get a common denominator. So the common denominator is going to be their product. So I'm going to multiply, let me rewrite this real quick. I'm going to multiply each fraction by the denominator factor that it's missing. So the first fraction is missing the x plus 3. I'll just put parentheses around any of the binomials. The second fraction is missing an x minus 4. Alright, so let's distribute it. So we're going to have 3x squared plus 9x for the first fraction. Do not, though, do anything with the numerator. Sorry, the denominator. Then you're going to do plus 2x squared minus 8x. So notice I distributed that there. Now let's combine our like terms. We have 3x squared plus 2x squared, so that's 5x squared. And then we'll have plus 9x minus 8x, so that's plus 1x. All over, keep that denominator as is. The numerator also has a GCF, so factor out that GCF, which is x. And then you're left with this. Now what if we take exactly the same question, but we make it a subtraction instead of an addition? The common denominator will still be the same. And the first part of the procedure will still be the same as well. So we're going to multiply numerator and denominator, because that's a factor of 1, by the missing portion of the common denominator. And so we just have to write the denominator one time. And we could write the numerators together. So we're going to have 3x squared plus 9x. But here's why this one's really important, because notice what you're doing is you're multiplying this negative 2x into this. So what you're going to get is negative 2x squared plus 8x. So be careful of this. When there's a minus sign, it will change the sign of everything to the right of it. So now you can combine your like terms. You have 3x squared minus 2x squared, so that's a positive x squared. And then you have 9 plus 8, and that's going to be 17x. And there's a GCF in the numerator, and the denominator stays in factored form. The last question we're going to do is what we call a complex rational expression. So a strategy on how to answer these types of questions is you look at all the denominators and you find a common denominator for those denominators. So you have 3x and 6. And a common denominator that they all would divide into would be 6x. Someone may say, oh, well, I think 3x. No, because the 6 won't go into 3x. So what you do is you find your common denominator and you multiply 6x over 6x, or common denominator over the common denominator, make it a factor of 1. Now, why this is important? Well, what you're doing is you're going to take this 6x and you're going to distribute to each of them. And notice that if for the first term, you're going to get 6x all over 3 plus 2 times 6x all over x all over x plus 4 over 6 times 6x. Now, there's a reason why I didn't do the multiplication step, because I want you to see, you don't really have to write this step, what I wrote in blue on the bottom here. What you have to realize is that the things are going to clean up real nicely, and you're going to be left with just no more denominators. So notice, with the numerator, I'm going to be left with 2x from this one, 2 times 6, and then the x plus 4 times x. And that's it. Let's just clean this up. 2 is a common factor in the numerator. And that's your final answer. Practice makes perfect on these. So keep trying multiple examples. They're all a little unique in their own way.